Well, in this lecture we are going to do a numerical example on simple optimization. Let's suppose the question is given as, all right, so this is the question and we want to optimize it. Clearly the different variable is only one, that is x. Okay, we have to apply first order condition and second order condition to optimize this function. So first of all, we need to apply first order condition. First order condition is we need to take the derivative of this function and we should put it equal to 0. So the derivative of this function, the derivative of 2x cube is this is equal to 2. The derivative of x cube is 3x square, and minus 30, the derivative of x square is 2x, and plus 126, and the derivative of x is 1, and the derivative of constant is equal to 0, and we put it equal to 0. So this is equal to 6x square minus 60x and plus 126, and we can put it equal to 0. We can take 6 common to further simplify this. If we take 6 common, we are left with x square minus 10x or plus 21, and we put it equal to 0. And if we divide both sides on 6, we are left with x square minus 10x plus 21, and we should put it equal to 0. Now you have the choice whether you want to solve it by factorization, by quadratic formula, or by computing square, or any other method. I am going to solve it by factorization. If I want to solve it by factorization, the factors can be x square minus 3x minus 7x. I decompose minus 10x into minus 3x minus 7x, which if I add, I get minus 10x, and if I multiply the two, I get 21x square plus 21x square. This is equal to 0. You can take x common and you get x minus 3 from these two, and from these two you can take minus 7 common and you will get x minus 3. Minus 3, why? Because when you take minus common, then the sign inside the bracket changes, right? So again you can take x minus 3 common from these two, so x minus 3 and x minus 7, and you put it equal to 0. Clearly x minus 3 is equal to 0, and so x minus 7 is also equal to 0, or x is equal to 3 and x is equal to 7. So these are the two critical values, right? So what I need to do is, now I have to confirm whether at which value at x is equal to 3, what is the position of the function, whether it is maximized or it is getting minimized, and what about the x is equal to 7. So I have to confirm this, at which value the function is getting maximized and at which value the function is getting minimization. So let us try it. So for this confirmation we apply the second order condition. So we need to apply second order condition. We need to apply second order condition. We have to take the second order derivative of this function. We have already taken the first order derivative, which is this one. So again take the derivative of this function again, right? So the derivative of 6x square minus 60x plus 126. So we need f double prime of x would become d by dx of what? Of 6x square minus 60x plus 126. 6x square minus 60x plus 126. So I have to take the derivative of this. If I take the derivative of this is equal to 12x minus 60. Now I have to evaluate it because it is not an absolute value, rather it is a function, right? So first of all I need to evaluate it at x is equal to 3, and according to the rule, If I found it negative, then the function will be maximized at x is equal to 3. Similarly, if at x is equal to 7, if I found it negative, so again the function will be maximized and vice versa. So f double prime of x at x is equal to 3, it will become 12 into 3 minus 60. Overall, if I calculate it, it is equal to minus 24, which is less than 0. So f double prime of x is negative. So it means that the function is maximized at x is equal to 3. The function is concave and is maximized at x is equal to 3. Now at x is equal to 7, f double prime of x, it is equal to 12 into 7 minus 60. If I calculate it, this is equal to plus 24 and this is greater than 0. According to the rule, if the second order derivative is positive, then the function is minimized at x is equal to that particular critical value. So in our case, at x is equal to 3, the function is maximized. Why? Because the second order derivative is negative. And at x is equal to 7, the function is minimized. Why? Because the second order derivative is positive. That's it. If I sketch the graph, look at the graph, we can also show it with the help of a graph. So this is the data. These are the first critical value is 3 and the second critical value is 7. I have also used some further values 2, 3, 4, 5, 6, 7, 8, and I have put all these values in the original function which you want to optimize in this function. I put 2, 3, 4, 5, 6 up to 9 in this function, and as a result I found the value of y like this, right? Then I plot it and I can see that at x is equal to 3, the function is at its maximum point, right? And at x is equal to 7, the function is at its minimum point. So this is the graphical verification of the first and second order condition. You can see the slope is 0 at x is equal to 3, right? This is because if you draw the tangent, it is 0. Similarly, you can see the first order derivative is also 0 at x is equal to 7, right? But beyond this, the slope falls down, and here beyond this point the slope goes up. So at this point, f prime of x is equal to 0, right? And f double prime of x, this is less than 0, right? And here too, f prime of x is equal to 0 and f double prime of x is positive, it is greater than 0. So this is the verification of the mathematical optimization of the given function. Thank you. Thanks for watching.